Okay, this is going to be a video for Algebra 2 for writing radicals in exponential form and vice versa, new for 2025. So here's the big thing you have to understand. When you look at something here, the top number is the exponent inside, and then you divide by whatever the root is, okay? So if my exponent is 3, and the root is 5, that's 3/5. This one sometimes causes confusion, but that's a 1 with a square root, okay? This here is a 4/3, okay? A y to the 6/3. Now, 6/3 would reduce to 2, okay? Same thing here. I would have x 36 over 4, y 30 over 4, z 38 over 4, okay? Now, 36 divided by 4 is 9. 30 over 4, 30 divided by 4, if I hit the fraction button, that gives me 15 over 2, okay? And then the z of 38 over 4, 38 divided by 4, and then hit the fraction button, that's 19 over 2, okay? Now, what do you do when they got these in the denominator? What this does is it just makes this negative. So if you have something in the denominator, it makes this negative. So this would be x to the negative 3. Now, what would this one be? Well, normally, this would be 7/4, which does not reduce, but I would also have the negative because that's underneath. This is x to the 6/3, and because it's underneath, it's negative. Well, negative 6 divided by 3 would be negative 2. Okay? All right? So you guys go ahead and try some. Now we're going to go the other way. We're going to write this in radical form. So basically, the idea is the exponent inside is 7, and that's a square root. This one, the exponent inside is 1, okay, but that's a 4th root. This, all right, so what this would look like, because it's negative, it would be underneath, okay? It is x squared with a cube root, okay? This right here, okay, would be underneath, okay? This would be 4th root of x cubed and y to the 5th, okay? Now, somebody say, well, Mr. Evans, what do we do with these? Well, in order to have these roots be the same, this number's got to be the same. So I got to get a common denominator. So really that's like x is 15 over 3 and y is 1/3, okay? So what is that going to be? 3rd root x 15 and y to the 1st. You don't have to write to the 1st, but that's what you'd have. This one, I'd have to multiply this by 3. So that'd be x to the negative 9/12. I'd have to multiply this one by 4. That's y to the negative 8/12. Okay, so what does that mean? 1 over 12th root, x 9, y 8. Okay? All right, you guys go ahead and try some. Okay, so we want to write these in exponential form. Now, here's what you're going to do. First thing we're going to do is deal with this inside. This would be x to the 4/5, and then I got this 10 on the outside. Now, what I'm going to do is I'm going to multiply that. Okay, so 4/5, put parentheses around it, times 10 gives me 8. So this is x to the 8th power. Okay, this one right here would be x to the 4/3, inside and root, then squared. So I'm going to multiply those. 4/3 times 2. Hit the fraction button. That's 8/3. Okay? This one, all right, what I'd have first is x to the 4/6, y to the 8/6, and I got this 4 here, so I'm going to multiply that. Okay? So 4/6 times 4, okay, is 8/3 for x. 8/6 times 4 is going to be 16/3 for y. Okay? All right. Now we're going to go the other way. We're going to write this in radical form. Okay? All right. So the idea is, all right, if it's inside the parentheses, I put 1s here to help me. So the idea is I'm going to multiply 1 times 2/5, which obviously is just going to be 2/5. So 2 to the 2 fifths. All right, and then x, 8 times 2 fifths. All right, 16 fifths. All right, now that means that I have the fifth root there. This would be 2 squared and x to the 16. Well, I know what 2 squared is. 2 squared would be 4, so 4x to the 16th. So this is what that would look like in radical form, okay? All right, so this one would be 8 to the 1/4. 1/4 times 8, okay? That's going to be 8/4, okay? All right, now, somebody say, well, Mr. Evans, if you do that, it should be 2. Yeah, and then what I'd have to do is I'd have to change it back to 8/4 so I can get it underneath of a radical. So it's 4, 8 to the first power, okay, x to the 8th power, where 8 to the first power is just 8. So this is what I'd have in that form. Now, this is a little different. See how this does not have the parenthesis. So what happened is the 12 stays here. This would be the third root of x to the 5th. Same thing here. That 5 stays up there. I would have 7x to the 6th, okay? All right, so notice how if it has parentheses, you actually have to deal with the exponent. If it does not, you do not have to deal with the exponent. Okay, go ahead and try some on your own. Okay, now the next ones involve properties. Okay, and with the coefficients, you can just type them into the calculator like you see them. So that's 10 times 7. All right, so that gives me 7. Okay, now, what you want to do, if you have a like base, you want to add those exponents. Okay, so 5/3 plus 7/3. Okay, and that tells me 4. Okay, and my exponents are positive. Okay, so this multiplication, 2 times 9, that's going to be 18. I want to add those negative 3/2. Okay, plus negative 11/2. That's going to be negative 7. Now, what that means is this is the only thing that moves. It goes underneath and becomes positive 7. So that's what the positive exponent deal. Okay, this means division, so I would divide 8 and 2. Okay, which would be 1/2. Now, what I'm going to do here is I'm going to subtract these. Okay, so 5 minus 6 is 5 minus 11 is negative 6. 15 minus 3 is 12. 7 minus 4 is 3. Now, this has to go underneath and join that, and the y12 z3 stays up top. Okay, now, what should I do with this one? Well, I should write this in exponential form first. So this is x to the 2/5. This is y to the 7/5. Okay, because that's the exponent, that's the root. This would be x to the 3/10, y to the 2/10. So I'm going to subtract those. I don't have any numbers out front, so I don't have to worry about that. 2/5 minus 3/10. Okay, I get for x 1/10. Okay, and then 7/10, or 7/5, I'm sorry, minus 2/10. All right, that's going to be 6/5. And since those are positive, I'm good with that. Okay, so multiplication, we're adding. Division, we subtract. Okay, all right. Okay, a couple more involving powers. We sort of have done these already. Okay, this, okay, I want to multiply, all right, 8 times negative 5/4 is x is negative 10, but since I want positive exponents, that's x with 10th in the bottom. This one, okay, is 2 to the negative 1/3, because that's a 1. Okay, I want to multiply that. Okay, and then I got 9 times negative 1/3. That's negative 3. Okay, now, how do I handle this? Okay, well, what this means is this means, okay, first of all, that this would go underneath, okay? This would mean cube root of 2. Now, does this simplify at all, okay? Or I'm sorry, I can actually do, I don't need to, I can actually write that, because we're writing with exponents, sorry. All right, that would be 2 to the 1/3 down here with a 1 there, okay? I can just leave that as it is, all right? Now this one, what I want to do is figure these out individually. So this would be 4 to the, I multiply that, would be 1/2. X, 8 times 1/2. Would be x to the 4th, okay? Times, all right, 27 to the 1/3 times 6 times 1/3. I got x squared. All right. So what am I going to get out of that? 4 to the 1/2. You should always check to see if it simplifies at all. That's going to be 2. So that's 2x to the 4th times 27 to the to the 1/3 power. So it'd be 3x squared. Well, I can just now multiply those. That's 6, and then I'm going to add these, so it's x to the 6th. All right. Square root, I got 25 to the 1/2. 1/2 times 14 would be 7. Then that would be 16 to the 1/4. 8 times a 4th is 2. All right. Let's see if what these are. 25 to the 1/2. That's going to be 5. X to the 7th. And 16 to the 1/4 power. That's 2. All right. So then I do 5 times 2. 10, add those exponents, x to the 9th, okay? All right, so those are all examples, okay? And then you would try the last bit. Those are all examples of converting radicals to exponents and exponents to radicals.